Hey there, and welcome. Today, we're going to jump into a really cool topic called prime factorization. Now, that might sound a little complicated, but trust me, it's actually all about finding the secret building blocks that are hidden inside every single number. Let's get started.
So here's our game plan for today. First, we'll learn a handy little trick called the exponent shortcut. Then, we'll talk about prime numbers, which are kind of like the Legos of math. After that, we'll figure out what prime factorization is, practice it together, and then we'll see why this is such a big deal for you in math.
All right, first up, the exponent shortcut. You know, math is packed with all these cool shortcuts to make our lives easier, and this one is a really good one to know. So imagine you had to write this out. 3 times 3 times 3 times 3. It's not too bad here, right? But what if you had to multiply it 10 times? Or maybe 100 times? No way. That would take up a whole page. There's got to be a better way.
And here it is, our awesome shortcut. This is called an exponent. So that big number on the bottom, the 3, we call that the base. That's our main number, the one we're multiplying. And that little number up top, the 4, that's the exponent. It just tells you how many times you need to multiply the base by itself. So we write it as 3 with a little 4, and we say 3 to the power of 4.
Okay, your turn. Have a look at this. How would you write 2 times 2 times 2 using this new shortcut? Think about it. What's the base and what's the exponent going to be? You got it. I knew you would. The base, the number we're multiplying, is 2. And since we're multiplying it 3 times, the exponent is 3. We write it just like this, and we read it out loud as 2 to the power of 3. See? Pretty simple. Awesome. Now that we've got that shortcut down, let's talk about the building blocks of all numbers. Seriously, you can think of numbers just like Legos. Everything is built from a few very special pieces. So it turns out there are really just 2 kinds of these number bricks. First, we have prime numbers. These are like those basic single Lego bricks. You can't break them down any smaller. The only way to divide them is by 1 and by the number itself. And then you've got composite numbers. These are like the cool things you build with the Legos. They're made up of smaller prime pieces all multiplied together. So take a look at these. We've got 2, 3, 5, 7, 11, 13, and the list just keeps on going forever. But you'll notice, hey, where's the number 4? Well, 4 isn't prime because you can do 2 times 2 to make it, right? What about 9? Nope, because that's 3 times 3. See? The numbers on this list are the real original building blocks. But what about the number 1? That's a great question. 1 is, well, it's a bit of a weirdo. It's so special that it's not prime and it's not composite. It's just 1. It's in its own little club all by itself. All right, we've got exponents, we've got prime numbers. Now we can put it all together for the main event. What is prime factorization? I know, it's a big, fancy phrase, but all it really means is breaking a bigger number down into its prime number Lego bricks. That's it. And don't worry, there's a super simple 3-step recipe for it. Step 1, just pick a number, let's say 12. Step 2, you're going to divide it by the smallest prime number you possibly can. Always try 2 first, then 3, then 5, and so on. And step 3, just keep doing that until all you have left are prime numbers. Let's try it. Okay, so we have our number, 12. Let's think, what's the smallest prime number we can divide 12 by? We always start with 2. Does 2 go into 12? Yep. And 12 divided by 2 is 6. Easy peasy. Okay, but wait a second. We're not done. Is 6 a prime number? Nope, we can break it down more. So we do it again. What's the smallest prime we can divide 6 by? Well, it's 2 again. And 6 divided by 2 gives us 3. Okay, so let's see what pieces we have. We used a 2, then another 2, and we were left with a 3. Now let's ask the big question. Are all of these prime numbers? Is 2 prime? Yes. Is 3 prime? Yes. We did it. We can't break them down anymore, so we stop. So to write out our final answer, we just multiply all those prime building blocks together. 2 times 2 times 3. And hey, wait a minute. Remember that shortcut from the very beginning? We've got 2 2's, so we can use our exponent trick and write it as 2 to the power of 2 times 3. How cool is that? See? You can totally do this. Now that we've got the recipe, let's try a slightly bigger number together. Don't worry, the steps are exactly the same. All right, here we go. What's the prime factorization of 60? Take a second and think. What's that very first step? Remember our rule. Always start by dividing by the smallest prime number you can. All right, let's do it today step by step. We start with 60. Can we divide by 2? You bet. That gives us 30. Now we have 30. Can we divide by 2 again? Yep, that gives us 15. Okay, now we have 15. Can we divide by 2? No, that won't work evenly. So what do? We just try the next prime number up, which is 3. Does 3 go into 15? Yes, it does. And that leaves us with 5. And what about 5? Is 5 a prime number? It absolutely is. So we're all done. So let's gather up all our prime pieces. We have a 2, another 2, a 3, and a 5. And if we want to light that using our fancy exponent shortcut, it's 2 to the power of 2 times 3 times 5. See? Same process. It works every time. And that's really it. You just learned a super important new skill in math. Let's just take a quick look back at everything you just mastered. Seriously, think about it. In just the last few minutes, you learned how to use exponents, a cool math shortcut. You learned the big difference between those basic prime numbers and the composite numbers they build. And, the most important part, you learned the step-by-step way to find the prime factorization of any number. And I really want you to remember this. This isn't just some random math trick. This is a huge deal. Prime factorization is, well, it's a building block for you. It's going to help you understand so many other things down the road, like fractions and algebra. You've just taken a massive step forward. So, I'm going to leave you with this one last thing to think about. You now know how to break numbers down into their secret, basic parts. So my question for you is, what do you think we can build with them? What other amazing things can we figure out now that we know the secret code? Thanks so much for learning with me today.